Beyond the edge of an event horizon, the universe as we know it ceases to exist. Space doesn't just bend. Time itself shatters. If you were to cross this invisible boundary, you wouldn't just be entering a place in space. You would be falling toward the absolute end of time. But what actually happens when physics breaks down and time stops making sense? To understand the breakdown of time, we must first confront the greatest conflict in modern physics: the irreconcilable war between general relativity and quantum mechanics. Albert Einstein taught us that space and time are not static arenas. They are woven together into a dynamic, flexible fabric called space-time. Heavy objects like stars and planets warp this fabric, creating what we perceive as gravity. For over a century, general relativity has flawlessly predicted the motion of planets, the bending of light, and the expansion of the cosmos. But on the infinitely small scale, quantum mechanics rules, a realm governed by probability, uncertainty, and subatomic chaos. Under normal circumstances, these two theories never need to meet. Relativity governs the massive, quantum mechanics governs the microscopic. Except in one place, the core of a black hole, where an enormous mass is crushed into a point of zero volume. Here, both theories are forced into the exact same space, and when they meet, the mathematics of physics collapse entirely. Imagine taking a journey toward a supermassive black hole. As you approach the event horizon, the boundary from which not even light can escape, the universe outside begins to look deeply distorted. To an observer, watching you from a safe distance, something miraculous happens. Because gravity slows down time, your clock appears to tick slower and slower relative to theirs. As you touch the horizon, the outside observer sees you freeze completely. Your image turns red due to extreme gravitational redshift, fading into darkness. To them, you never actually cross the horizon. But from your perspective, falling in, nothing special seems to happen at the boundary. Your clock ticks normally. You pass right through the point of no return. Once you cross the event horizon, however, the fundamental geometry of reality undergoes a radical inversion. Outside the black hole, you have freedom in space. You can move forward, backward, left, or right, but you are trapped in time, always moving relentlessly into the future. Inside the horizon, space and time swap roles. The center of the black hole is no longer a location in space. It is a moment in your future. Moving toward the singularity becomes as unavoidable as moving into tomorrow. As you descend toward the center, tidal forces skyrocket, stretching matter into microscopic strands, a process known as spaghettification. But the true mystery isn't what happens to your body, it is what happens to time. At the theoretical center lies the singularity, a point where density becomes infinite and the curvature of space-time reaches an absolute limit. According to general relativity, at the singularity, time simply stops existing. It is not an infinite duration. It is the boundary where the concept of before and after loses all physical meaning. Yet, quantum physicists believe a true infinity cannot exist in nature. Theories like loop quantum gravity suggest that space and time are made of tiny, indivisible quanta, atomic building blocks of reality itself. In this quantum view, time doesn't break into nothingness. Instead, space-time reaches a maximum density limit, creating a Planck Star, a quantum bounce where black holes might eventually evaporate through Hawking radiation, releasing all trapped information back into the universe over quintillions of years. Black holes are not merely cosmic destroyers or gravitational traps. They are the ultimate laboratories of nature, places where time, space, and quantum reality are tested to their absolute limits. They remind us that the universe is under no obligation to conform to human intuition, and that our understanding of reality is still only in its infancy. If you wish to continue exploring the frontiers of reality, subscribe and join us on our journey across the quantum cosmos. Until next time.